students, welcome back to today's Vidyanagar online science class. And I am here with you to continue our 10th physics chapter, Gravitation. In today's class, we are going to discuss about motion of an object under the influence of gravitational force of the earth, comparison between small g and capital G, and finally mass and weight. So today's point of discussion: motion of an object under the influence of gravitational force on the earth, comparison between small g and capital G, mass and weight. Okay, so let's start our today's class. As you know, the object falls freely towards the earth is free fall, or the motion of an object under the influence of gravitational force is termed as free fall. When an object falls freely towards the earth, we can consider them as the free fall. The motion of an object under the influence of gravitational force is termed as free fall. Okay, when an object falls down, take G equal to positive. When an object falls freely down, consider acceleration due to gravity G equal to positive. And when we throw an object up, take G equal to negative. So this will be helpful to do the problems. When an object falls freely down, take G equal to positive. When we throw an object up, there you have to take G equal to negative. Okay, simple thing, right? So the usual action of an object is falling down, right? So when an object falls down, take G equal to positive. Instead of that, if we throw that object to up, there we have to use G equal to negative. So only in case of problems, we have to use these concepts or these points only in case of problems. Okay, so if an object falls freely under the influence of gravity, that is free fall. When an object falling freely, there G equal to positive, or if we throw that object up, G equal to negative. In case of falling freely, G equal to positive. When we throw the object to up, take G equal to negative. Just like while an object falling down, they experience an acceleration, right? When an object falls freely down, they experience acceleration. So that acceleration due to gravity is small g, right? But the point which we are going to concentrate here is that acceleration independent of mass. That acceleration is independent of mass. It does not affect the mass, or that acceleration is not depending the mass. When an object falls freely, they experience an acceleration. This acceleration is independent of mass, or it does not depend upon the mass. So that the object, small, big, falls down at the same time. Why the objects fall down at the same time or the same rate? Because that acceleration is not depending the mass. The acceleration is independent of mass. Why the big object or the small objects falling down at the same rate? Because the acceleration is independent of mass. So this concept was proved by Galileo Galilei. So Galileo Galilei proved this concept. What concept? The objects, whether it is small or big, falls down at the same rate. Which means acceleration is not depending the mass. Acceleration is independent of mass. Only this point you have to keep in your mind. Why big object or the small objects is falling down at the same rate? Because acceleration is independent of mass. It does not depend the mass. That's all. Okay, so why these objects falling down at the same rate? Because acceleration is independent of mass. Acceleration does not depend upon the mass. That's why it is falling down at the same time or same rate. Okay, And we have discussed in our previous classes about the equations of motion, right? We have three equations of motions like v equal to u plus at, s equal to ut plus half at square, v square minus u square equal to 2as. But now we are discussing about gravitation. So in gravitation, instead of acceleration, you have to use acceleration due to gravity. So how we will rewrite the equation rewrite the equation by using the acceleration due to gravity. So our equation is, first equation is v equal to u plus at. So how to change that? V equal to u plus gt. Why? Because here instead of acceleration you have to use acceleration due to gravity. Okay, and what about second? S equal to ut plus half at square. So that equation you have to write S equal to ut plus half gt square. S equal to ut plus half gt square. And the next one, v square minus u square equal to 2as. So v square minus u square equal to 2gs. V square minus u square equal to 2gs. So v equal to u plus gt, s equal to ut plus half gt square, v square minus u square equal to 2gs. Why? Because here instead of acceleration you have to use acceleration due to gravity g. That is v equal to u plus gt, s equal to ut plus half gt square, v square minus u square equal to 2gs. Okay, so why the objects falls towards down at the same rate? Because acceleration is independent of mass. Acceleration not depend the mass. Who proved this? Galileo Galilei. Okay. Now we can compare capital G and small g. What are the differences between small g and capital G? Okay, look at the board. First one, capital G, small g. Okay, what is capital G? Capital G is gravitational constant. Capital G is gravitational constant. And what is small g? Small g is acceleration due to gravity. So the first difference is capital G is gravitational constant. Gravitational constant. And the small g is acceleration due to gravity. And the second one, it's units. How the units, small capital G, the unit, the SI unit is Newton meter square per kilogram square. Newton meter square per kilogram square. And what about small g? Small g is meter per second square. First one, g is gravitational constant. Small g is acceleration due to gravity. And the second is unit. The unit of capital G, Newton meter square per kilogram square, and small g, meter per second square. And what about their value? The value of capital G is 6.673 into 10 raised to minus 11 Newton meter square per kilogram square. The value of capital G, 6.673 into 10 raised to minus 11 Newton meter square per kilogram square. And here it is 9.8 meter per second square. So the value of G, 9.8 meter per second square, small g. Okay, and the next one, capital G is constant. Capital G is constant everywhere. It's a constant. But small g varies from point to point. Small g varies from point to point. Acceleration due to gravity varies from point to point. See, are you remembering that? The value of small g, g is greater at the poles than the equator. G is greater at the poles than the equator, right? So there itself, two values. Greater at the poles than the equator, which means G is not a constant. It varies from point to point, but capital G is a constant. Wherever we go, we use the same number for the capital G. And the next one, capital G is scalar quantity. Capital G is scalar quantity. What is scalar quantity? Scalar quantity is a quantity which has only the magnitude. So for capital G, there is only magnitude. So it's a scalar quantity. But acceleration due to gravity is a vector quantity because it has both direction and magnitude. I told you whether it is, if the object is falling down, G is positive. Whether the object is going up, G equal to negative, which means there the magnitude and the direction. If the quantity have both the direction and magnitude, such quantities are scalar, vector quantities. Such quantities are vector quantities. Okay. And the last difference, see the value, here it is 6 point and this is 9 point, which means the value of capital G is small and the value of small g is big. 6 point and 9 point. So the bigger value is small g. So the value of capital G is small and the value of small g is big. So what are the differences between small g and capital G? First one, capital G is the gravitational constant. Capital G is gravitational constant. Small g, acceleration due to gravity. And the unit of capital G, Newton meter square per kilogram square. And here meter per second square. And value 6.673 into 10 raised to minus 11 Newton meter square per kilogram square. 9.8 meter per second square. Then it's a constant. Gravitational constant is a constant, but acceleration due to gravity varies from point to point. Like the value of G is greater at the poles than the equator. So there is different values for G, the small g. So it varies from point to point. And capital G is a scalar quantity because it has only the magnitude. So the capital G is a scalar quantity, but acceleration due to gravity has both the magnitude and direction. So it's a vector quantity. And the last one, the capital G is a small value like 6.673 to 10 raised to minus 11, but the small g is 9.8. So it's a big value, right? So capital G is a small value and small g is big value. So these are the differences between capital G and small g. Okay. Let's discuss very important points, mass and weight. What are the differences between mass and weight? Normally we use the terms mass and the weight simultaneously, right? But mass and weights are
entirely different concepts.
First we can discuss about the mass. What is mass? Mass is the quantity of matter present in an object. Mass is the quantity of an object or quantity of matter present in an object. Or simply, mass is the content present in the object. Mass is the content present in an object. How much content present in an object? So that is mass. So what is mass? Mass is the quantity of matter present in an object. Or it is a content present in an object. It's a simple concept, right? Mass means what? Mass is the content present in an object, or it is the quantity of matter present in an object. Okay, and you have learned from that, previous chapters that mass is the measure of inertia, right? We have discussed that. Mass is the measure of inertia. Or greater the mass, greater its inertia. That also we studied, right? Which means mass is same everywhere. Mass is same everywhere. It is constant. Mass is same on the earth or on the moon or even the outer space. Mass is same, which means mass is constant everywhere. Why? Because mass is the content present in an object, or it is the quantity of matter present in an object. It never changes. So that is constant. So 2 points now we discussed. What is mass? Mass is the content present in an object, or it is the quantity of matter present in an object. And it is constant. It is same everywhere. Wherever we go, we can use or we will get the same mass. It never changes. Okay, and the third case, the SI unit of mass is kilogram. What is SI unit of mass? The SI unit of mass is kilogram. The SI unit of mass is kilogram. The SI unit of mass is kilogram. So what is mass? Mass is the quantity of matter present in an object, or it is the content present in an object. It is constant. It never changes. And the SI unit of mass is kilogram. The SI unit of mass is kilogram. Okay. Then SI unit of mass is kilogram. Got it? So what is mass? Mass is the content present in an object or it is constant. The SI unit of mass is kilogram. And the next one, mass is scalar quantity. Mass is scalar quantity. Why? Because it has only the magnitude. 5 kg, 2 kg, 3 kg. Only you have to express the magnitude. You don't want to specify any direction. Can we specify any direction? No, it's only a value. That's why mass is scalar quantity. Mass is scalar quantity. Mass is scalar quantity. And the next one, mass never becomes zero. Mass is never zero. See, at least we will get at least point value there. We will not, that means mass is never zero. Mass is never become zero. So mass is the content present inside the object, or it is the quantity of matter present in an object. It is constant and SI unit is kg. It is a scalar quantities. It is never zero. It is always, we will get some values. Mass is never zero. So these are the points you have to study under the mass. Okay, so mass is the content present in an object. It never changes. Then what is weight? Then what is weight? See, as you know, every object is attracted towards the earth, or earth pulls every object towards its center. So weight of an object means it is the attractive force between that object and the earth. So what is weight? Weight is the attractive force between that object and earth. So if I'm talking about my weight, what is my weight? My weight is the attractive force between my body and the earth. So that attractive force is the weight. Got it? So how to define then? Weight of an object is the force with which it attracted towards the earth. So weight is the force with which it is attracted towards the earth, or it is the attractive force between the object and the earth. So hereafter you don't change mass and weight. Mass is the content present in an object, or weight is the attractive force between that object and the earth. So it is the weight is the force with which earth is attracted, or it is the force with which that object is attracted towards the earth. So weight is the force with which it attracted towards the earth. So the attractive force between that object and earth is the weight. Okay, and the SI unit of weight. Okay, before describing the SI unit, let me give you the equation. Right? What is weight? Weight equal to, weight is the attractive force between that object and earth. And we already studied that F equal to mg. F equal to mg. So what is this? This is force now. This is force. What is weight? Weight is the force between that object and the earth. Weight is the force between the object and earth. So you can write the equation for weight, W equal to mg. W equal to mg. Why? Why W equal to mg? Because weight is the attractive force between that object and the earth. Same, F equal to mg. So same equation you can use for the weight. Weight W equal to mg. Weight W equal to mg. Weight W equal to mg. So weight is attractive force between that object and the earth, or weight is the force with which it attracted towards the earth. And what is the equation for weight? Weight equal to mg. And so it's an attractive force now. Weight is an attractive force. So you can use Newton as the unit. So it is the unit of weight, Newton. Why? Because it is an attractive force between the object and earth. So which is the unit for force? Newton. What is the unit of mass? Kg. And the unit of force? Unit of weight? Newton. And now I am standing now. So my body is acting force towards down. Which means weight is a vector quantity. Weight is a vector quantity. Why? There we have to mention about the magnitude and the direction. Right? 5 newtons to downward or 5 newtons to upward. So there we have to specify the magnitude and direction. So weight is a vector quantity. Weight is a vector quantity. So weight is the attractive force between the object and the earth. It's a vector quantity and the unit is Newton. Equation W equal to mg, and weight is not a constant. Weight is not a constant. According to the point, the weight changes. Why? Because g is not a constant. G is not a constant, right? G vary from point to point. So the weight also not constant. And weight becomes 0. Weight becomes 0. Why? Because at the center of the earth, value of g is 0. At the center of the earth, the value of g is 0. Where is the value of g is 0? The value of g is 0 at the center of the earth. So at the center, there is no weight. At the center of the earth, we will feel weightless. Why? At the center of the earth, we will feel weightless means there is no weight. Weight equal to 0. Why weight equal to 0? Weight equal to 0 because g equal to 0 at the center. So W equal to 0. We feel weightless at the center of the earth. Why we feel weightless at the center of the earth? Because at the center weight is 0 because g equal to 0. So W equal to 0. So that's why we will feel weightless at the center. Okay, so what about mass? Mass is the content present in the object, or it is the quantity of matter present in an object. It's a constant. SI unit is kg and it's a scalar quantity. Mass is never become 0. Right? And weight is the attractive force between that object and earth, or weight is the force with which it is attracted towards the earth. Weight is a vector quantity because both magnitude and direction. W equal to mg. Weight is 0 at the center because g equal to 0. And weight is not a constant because g is not a constant. G varies from point to point. Then how we compare mass and weight? See, mass, weight. Mass is the content inside the object. Definition. Mass is the content inside the object. Weight is the force with which it attracts towards the earth. It attracted towards the earth. Force with which it attracted towards the earth. Then mass is constant. But weight is not constant because it changes from place to place because g is not a constant. G varies from point to point. That's why weight is not a constant because W equal to mg, right? W equal to mg. So if g is not a constant, weight also is becoming not a constant. Okay. So it changes from place to place. Why the weight is not a constant? If anyone asks you, you have to know that W equal to mg. W equal to mg. In that g is not a constant. G varies from point to point. That's why weight is not a constant. Weight also changes from point to point. Why weight changes point to point? Because g changes from point to point. That's why weight also changes. Okay. So mass is constant. Weight is not a constant because it changes from place to place. And the unit kg, the unit of mass kilogram, and the unit of weight Newton because it's a force, right? And mass is a scalar quantity. Weight is a vector quantity. Then mass is never 0, but weight is weight of the body 0 at the center because g 0 at the center. That's why we feel weightless at the center. So the differences are: mass is the content inside the body, weight is the attractive force between the object and earth, which means force with which it attracted towards the earth, and mass is constant. Weight is not a constant, it changes from place to place because W equal to mg. In that g changes from place to place. That's why weight also changes from place to place. And the SI unit of mass is kilogram. The SI unit of weight Newton. Mass is a scalar quantity because it has only magnitude, and it's a vector quantity because both the magnitude and direction. And mass is never 0. Okay. And weight of the object is 0 at the center, because at the center g equal to 0. So w equal to mg. If g equal to 0, w equal to 0. So weight is 0 at the center. That's why we feel weightless at the center. Okay. Weight is directly proportional to mass. Weight is directly proportional to mass. If mass increases, weight increases. If mass increases, weight increases. So how the mass and weight is connected? Weight is directly proportional to mass. So keep it in your mind. W is directly proportional to mass. So that's you keep in that mind. W is directly proportional to mass. Weight is directly proportional to mass. When there is any change in the mass, there is change in the weight. Okay. So weight is directly proportional to mass. Okay. So now we are going to discuss about the weight of an object on the moon. How the weight of the object, or we are going to compare the weight of the object on the moon and weight of the object on the earth. Okay, so you can see in your textbook lot of calculations, so that calculations are not necessary. Okay, so you don't want to by heart that calculations, you just go through it, but these lines are very important. So these lines you keep in your mind. Wm, weight of the object on the moon. Okay, and We, weight of the object on the earth. So how the weight of the object on the moon and weight of the object on the earth is connected? Wm by W equal to 1 by 6. Wm by W equal to 1 by 6. What is Wm? Weight of the object on the moon. And We, weight of the object on the earth equal to 1 by 6. Equal to, that ratio is 1 by 6. That means weight of the object on the moon equal to 1 by 6. See, weight of the object on the moon equal to 1 by 6 into weight, 1 by 6 into weight of the object on the earth. Okay, so weight of the object on the moon by weight of the object on the earth equal to 1 by 6, which means weight of the object on the moon equal to 1 by 6 of its weight of the object on the earth. 1 by 6 into weight of the object on the earth. So the weight of an object on the moon equal to 1 by 6 its weight on the earth. So it's the object's 1 by 6th portion of the weight only we will feel on the moon. So that much small. So weight of the object on the moon is equal to 1 by 6 the weight of the object on the earth. So the weight of the object on the moon is equal to 1 by 6th portion of the weight of the object on the earth. Okay, so weight of the object on the moon equal to 1 by 6 of weight of the object on the moon. So it's that much small weight we will feel on the moon, right? So this relationship you just keep in your mind. Weight of the object on the moon equal to 1 by 6 weight of the object on the earth. Okay, so it's 1 by 6th portion only we will feel on the moon. So the actual weight of the object on the earth, it's 1 by 6th portion only we will feel on the moon. So weight of the object on the moon equal to 1 by 6th weight of the object on the earth. Okay, weight of the object on the earth is the force with which earth attracts that object. So the weight of the object on the earth is the force with which earth attracts that object. Just like the weight of the object on the moon is the force with which the moon attracts that object. What is the weight of the object on the moon? Weight of the object on the moon is the force with which moon attracts that object. Weight of the object on the earth is the force with which earth attracts that object. Just like force with which the moon attracts that object is the weight of the object on the moon. Right. And the mass of the moon is less than that of Earth. The mass of the moon is less than that of Earth. Due to this reason, moon exert lesser force on object. Why the moon exert lesser force on object? Because mass of the moon is less than that of the Earth. Mass of the moon is less than that of the Earth. That's why moon exert lesser force on object. Moon exert lesser force on object. So the mass of the moon is less than that of the Earth. Due to this reason, moon exert lesser force on the objects. Okay, so that's all about today's class. We discussed very important points in our today's class. So understand all these concepts. It will be very helpful for your exam, and we will meet you soon with new concept in the new video. Till then, bye. Thank you for watching. Have a great day ahead.